Pinto Physics YouTube channel. I will start a laser chapter. First of all, what is laser? Laser, laser. It stands for light amplification, light amplification by stimulated emission of radiation. Laser emission, laser emission involves three process. First, absorption. Second, emission. Emission is divided into two categories. First, spontaneous emission. Second, B, stimulated emission. Laser. It stands for light amplification by stimulated emission or radiation. Laser emission involves three processes. First, absorption. Second, emission. Emission is divided into two categories: spontaneous emission and stimulated emission. Take one by one. I will describe. Take one by one and detailed explanation. First, absorption. Let us consider two energy levels E1 and E2 and their levels contain N1 and N2 number of atoms per unit volume respectively. here energy level 1, energy level 2, energy level 1 and energy level 2, energy transition from level first to transition level second, N1 and N2, photon of energy h nu equals to E2 minus E1, here N1 and N2 are the number densities of E1 and E2, E1 and E2 respectively. If a photon of energy h nu E2 minus E1 is incident on the system, then the atom will be excited to energy level E2. Here, consent absorption. What is absorption? That let us consider two energy levels, E1 and E2. Here, energy levels E1 and E2, and their levels contains N1 and N2. N2. Number of atoms per unit volume respectively. Number N1 and N2 contains number of atoms per unit volume respectively. Here N1 and N2 are the number densities of E1 and E2 respectively, where E1 and E2 is the energy levels having that means N1 and N2 is the number density. If a photon of energy h nu equals to E2 minus E1 is incident on the system, then the atom will be excited to energy level E2. Here, from energy level E1 to energy level E2. rate of absorption, rate of absorption under bracket number of atoms, number of atoms per unit volume per unit time per unit time absorbed close bracket are given by dn1 upon dt equals to minus n1 b12 mu u new equation first, where b12 Einstein coefficient for absorption, where B12 Einstein coefficient for absorption U nu is equals to number of energy density per unit spectral frequency range N1 number of atoms per unit volume in level first. Here energy level E1 and E2, N1 and 2 atom you provide some energy, then number of atoms per unit volume is excited from this level to this level. That means the photon of energy h nu is equals to E1 minus E2. E1. absorption absorption is always a stimulated process. Absorption is always stimulated process. Stimulated means induced. It means some external photon will induce this process. Second point, I will discuss emission. Emission is divided into two categories. पहला spontaneous emission. I will repeat. Absorption is always a stimulated process. Stimulated means induced. It means some external photon will induce in this process. That means some external photon. I will say that h nu equal to E2 minus E1. That means induced of energy. And emission is divided into two categories. First, spontaneous emission. Second, stimulated emission. Take one by one. I will take one by one. Spontaneous emission. In the spontaneous emission process, in the spontaneous emission process, atoms spontaneously decay. Decay to lower energy state. Spontaneous means random. Spontaneous means random. Rate of spontaneous emission rate of spontaneous emission या ब्रैकेट में number of atoms per unit number of atoms per unit volume per unit time emitted. Rate of spontaneous emission या bracket में number of atoms per unit volume per unit time emitted. That means dN2 upon dt is equals to minus of N2 A21 equation second. Where dN2 upon में dt is equals to minus N2 A21 second equation where A21 Einstein coefficient for spontaneous emission where energy level we will draw A1 and A2 as spontaneous emission. Here energy transition from second level to first level. In absorption energy level transition from 1 to energy level second, but in a spontaneous process energy level transition from E2 to E1. Here N1 and N2 number density, N2 denoted by numbers of atoms per unit volume, number of atoms per unit volume in level second. In absorption process N1 number of atoms per unit volume in level first. Couch energy level transition from level first to second, but in the spontaneous process energy transition from level E1 to energy level E2, where A21 equals to 1 upon tau 21. This is called Einstein coefficient. Einstein coefficient. This is called Einstein coefficient, where tau 21 is equals to lifetime of level lifetime of level 2 for lifetime of level 2 for transition in level first. Here I will read tau 21 equal to lifetime of level 2 for a transition in level first, lifetime of level 2, lifetime of level 2 for transition level 1. I will discuss 2 levels, but also I discuss in 3 levels of transition. Level of energy transition, one by one. I will discuss in 3 levels of energy transition. Energy transition level 3, energy transition level. I will take E not energy levels, second E2, A3, but here it is denoted by energy level E0, E1 and E2. I will denote energy level, 3 energy level, E0, E1, E2. Here energy transition N2, here let N0, N1, N2, energy transition from N2 to energy transition 0 level, N2 से N0 लेवल का एनर्जी ट्रांजिशन हो रहा है, इसका इंडिकेट करते हैं tau 20 से. This is indicated lifetime tau 21. इसका जो एनर्जी ट्रांजिशन हो रहा है वो सेकेंड लेवल से फर्स्ट लेवल, और इनका जो एनर्जी लेवल 2 से 0 लेवल तक एनर्जी ट्रांजिशन हो रहा है. जो इनमें जो फोटोन ऑफ एनर्जी का जो इमिशन होता है, इंड्यूस्ड होता है, वह एनर्जी इंड्यूस्ड कितना होता है, यहाँ पे जो एनर्जी इंड्यूस्ड होगा फोटोन का एनर्जी, वो आपको E2 माइनस E1 दिखेगा, E2 माइनस E1। लेट अस यहाँ कंसीडर कर लेते हैं, लेट अस कंसीडर we have a third level and transition from E2 to E1। फर्स्ट जो ट्रांजिशन है वो E2 से E1 पे हम कर रहे हैं, and transition from E2 to E0 are possible. Here two types of energy transition possible, E2 to E1 and E2 to E0 are possible for so two transitions are possible. Here two transitions possible for same level के लिए टू एनर्जी ट्रांजिशन पॉसिबल्स है। कैलकुलेट नाउ we can calculate the lifetime for level 2. Now we can also calculate energy levels of we can also calculate lifetime for level 2. We can calculate 1 upon tau 2 equals to 1 upon tau एनर्जी लेवल 2 से 1 आ रहा है, तो हम लाइफ टाइम क्या लेंगे, tau 2 1 प्लस, अब एनर्जी लेवल कहां से ट्रांजिशन हो रहा है, सेकेंड से ले करके कहां तक, E0 तक, तो हम जो लाइफ टाइम लेंगे वो कितना लेंगे, tau 2 0। ओके, and also I will convert Einstein in term of Einstein coefficient, that means A2 equals to A21 plus A2 naught. It is converted in term of Einstein coefficient. In terms of Einstein coefficient. Lifetime is converted in term of lifetime Einstein coefficient. I will discuss also about unit of Einstein coefficient. Unit of Einstein coefficient. Unit of Einstein coefficient. A21 equals to 1 upon me lifetime of energy level 2 to 1. That means energy transfer from 2 to 1. That means second inverse, yeah, Hertz. Now we have equation second, d n2 upon me dt equals to minus of n2 a21. That means I will also convert in term of lifetime period, lifetime. That means dn2 upon dt equals to minus n2 upon, I will written as the tau 21 if number of atoms per unit volume, number of atoms per unit volume, yeah, atomic density per unit, number density at t equals to 0, then n2 t equals to 0 equals to n2 t. Then calculate then calculate, then we can calculate n2 t. Energy density of level second at t equals to 0, n2 0, n2 t, n2 lower limit n2 0 to n2 t. That means मान लीजिए कि जो t0 मैं जीरो टाइम में जो है इनिशियली एट द जीरो इंटरवल ऑफ टाइम में n2 0 हियर, और सब इंटरवल ऑफ टाइम के बाद क्या हो जाता है कि जो नंबर ऑफ एटम्स है एनर्जी लेवल 1 टू एनर्जी लेवल 2 में ट्रांजिशन कर जाता है, तो उस वक्त जो टाइम टेकन लगता है वह t इक्वल्स टू जो है t इक्वल्स टू t लगता है। तो उस वक्त जो एनर्जी डेंसिटी होता है वो N2T होता है। अब आप जानते हैं कि फ्रॉम इक्वेशन सेकंड dN2 अपॉन में dt इज इक्वल टू माइनस ऑफ जो है N2 upon lifetime of tau2 1. So we also written as dN2 upon में N2 is equals to minus of dt upon में tau2 1. Put the value here. dN2 upon में dN is equals to minus of dt upon tau2 time at the first level. That means in when an atom presents in energy level first, we will provide some energy, then atom will be excited from level first to second level, then 0 to t, and let us suppose that initially at t equals to 0 and some interval of time t equals to t time में आपका क्या होगा, जो आपका एटम जो है, मॉलिक्यूल जो है, जो भी हो, इलेक्ट्रॉन जो है एक्साइट कर जाएगा नेक्स्ट लेवल पे, E2 लेवल पे, उस वक्त जो टाइम होगा वह t होगा। देखिए इनका जो इंटीग्रेशन होता है z और dz, देखिए यहाँ पे इनका जो इंटीग्रेशन होता है जानते होंगे कि z dz log z होता है, ठीक है। तो आप इसे लिख सकते हैं log z लोअर लिमिट अपर लिमिट n2 0 n2 t इज इक्वल टू, देखिए यहाँ पे कांस्टेंट है, ये आपका वेरिएबल है, आउटसाइड ले लीजिए, -1/2 इनको t कर दीजिए, ठीक है। अब देखिए अपर लिमिट माइनस लोअर लिमिट, दैट मीन्स log n2t minus of log n20 equal to minus t upon में a tau2 here also written as log m minus n log m by upon n log m upon n equals to, here also written ty tau2 I will written as log n2t equals to minus of n2 0 t upon में lifetime of tau2 here here n2, here eliminate logarithm, then exponential function, showing that in the right side, so n2 t equals to e to the power minus t upon में tau2 upon n2 0 Okay, so N2 energy density at T equals to T, and two levels of energy density equals to N2 0 e to the power minus T upon में dot Q1. Here, let third equation that means atoms decay, that means atoms decay spontaneously. Now I will discuss second part, emissions of second part, stimulated emission. Stimulated emission. Stimulated emission. It is not a random. It is not a random process. Stimulated emission. It is not a random process. यह random process नहीं है. It is a induced. It is a induced process. It is a induced process when a photon of frequency h nu equals to E2 minus E1. Here E1, E2 energy transition from E2 to E1. H nu E2 minus E1 N1 N2. It is a induced it is a not a random process. It is an induced process when a photon of frequency h nu equals to E2 minus E1. Interacts with an excited atom, then incident photon, then incident photon is coherently superimposed superimposed over emitted photon. Here, stimulated emission. It is not a random process. It is an induced process. When a photon of frequency h nu equals to e2 minus e1 interact with an excited atom, जो भी एटम होते हैं वो जो एक्साइट करते हैं उनको क्या करते हैं, interact with an excited atom, जो भी excited atom होते हैं, then incident photon is coherently superimposed over emitted photon. जो भी photon emit होते हैं वो क्या हो जाते हैं, superimpose कर जाते हैं एक दूसरे पे. Now these two photons induced the emission of more photon and go on multiplication until certain power level reached. This emitted light is known as laser light. Stimulated process is not a random process. Stimulated process is not a random process. It is an induced process. rate of stimulated emission rate of stimulated emission, that means number of atoms per unit, number of atoms per unit volume, number of atoms per unit volume I will somewhat. So next day, after this sentence, I will discuss next day. Start after this sentence. So thank you, all of you.